we should get started. What is your question, Afif? And whoever just joined us, good morning. So we'll go through periodicity today, which is to do with inorganic chemistry. So inorganic chemistry is everything to do with metals and non-metals. So you know it's a big chunk, it's a big topic, obviously, in A-level chemistry. So unless you can master it, you can forget about 33%, which is 1/3 of the whole AS level chemistry. So let's get started. What question you wish for me to cover today? Because you have done this, right? You have gone through this, right? Okay, so the question will come from me rather than from me. And I'll be waiting. Paper 1, paper 2, up to you. Whichever one you want me to go through. I uploaded this about a week ago. That is around 7 days ago. I'm here for you. So any questions you want to ask, I am yours for 1 hour. Well, less than 1 hour now. So let's get cracking. I will just wait until you ask me questions. Because questions come from you. And that is what I'm paid to do. If you're only going to go through the questions now, there is nothing I can do except wait for you. Hello. Not the first week already. If got no questions, we'll sit here for 1 hour and wait for you, because you know it is your tutorial, not my tutorial. So must be getting 100% now in your AS level.
Hello, sir.
Hello, what question do you want me to go through?
Question 7.
Paper 2, yeah?
Yeah, paper 2.
Okay, so I assume the rest of that, okay. So in this question, we are given some oxides and some chlorides. These are straight from your syllabus. You must know everything about the oxides and the chlorides. And we have this sodium oxide, sodium chloride, all the way to phosphorus 5 oxide and phosphorus 5 chloride. For each of these, you must be able to write the formula. So you have Na plus O2 minus, so it's Na2O, MgO, because Mg2 plus and O2 minus. These are straight formula from O level, Al3 plus and O2 minus. So as you know about the crisscrossing, these are what you call the valency based on the charges, and then you crisscross. That means you need 2 of that Al3 plus and you need 3 of that O2 minus for the charge to cancel. Silicon 4 oxide, that is silicon plus 4, that is silicon plus 4 there, and 2 oxygen, each one is -2. Phosphorus 5 oxide, phosphorus 5 oxide is phosphorus plus 5. This is P4O10. The empirical formula, of course, empirical formula, the definition is O level. The simplest whole number ratio of your atoms is P2O5, but this is not molecular. That is empirical formula. The molecular formula, the actual number of atoms in one single molecule is P4O10 in one single molecule. Between non-metal and non-metal, you have covalent bond. This one also covalent bond, but this is giant molecular. This is simple molecular. You could see from the properties, simple molecular, relatively low melting and boiling point, but here is sublimes, sublimations, again, O level, solid going to gas. This is very high melting point as a result of the giant covalent structure. The structure of SiO2 is an O-level topic under structure and bonding. Describe the structure of SiO2, how it looks like and whatnot. This is NaCl, sodium chloride, giant ionic structure, Na plus Cl minus, obviously, like that. So that's just NaCl, NaCl, Mg2 plus and Cl minus. That means you must have 2 Cl minus in order to balance out the charge. Aluminium chloride, AlCl3. This is a case study in AS structure and bonding under dative covalent bond, because you know that it will be simple molecular and it will sublime to give you Al2Cl6 dimer, of which I did show you how to draw Al2Cl6 previously, dative covalent bond AS syllabus. Silicon 4 chloride, between the nonmetal and the nonmetal, SiCl4 looks just like a tetrahedral methane, CH4. Carbon is above silicon. Chlorine, like hydrogen, forms single covalent bonds. So it looks like methane there. Phosphorus 5 chloride, phosphorus plus 5. This is going to be PCl5. In your syllabus, you know you use PCl5 to turn alcohol into halogenoalkanes. So you would do alcohol and then becoming RCl by using PCl5. And you should be able to write an equation for that. ROH plus PCl5, you get the halogenoalkane where you replace the OH with Cl, and then you will get HCl, steamy white film, and you get POCl3. Balancing equations in organic chemistry is AS. In A2, you convert carboxylic acid into acyl chloride, that is A2 for the same equation using PCl5. Anyway, this first question is about melting point, melting temperature or melting point. There are two things to it. The first one is silicon 4 oxide, there's your part 1. The next one is silicon 4 chloride, there's your part 2. So there are 2 marks associated with these questions because you cannot just talk about one thing and not about the other one. To do these kind of questions, you have to be aware that you are doing, I'm just showing my face, but sometimes looking at the screen for so long, people might just fall asleep. So silicon 4 oxide, meaning SiO2, silicon plus 4, silicon 4 oxide, it has a giant covalent structure. Okay, so you should know this from structure and bonding, which I did recap with you previously. So when you melt it, melting, right? Because the question asks you on melting. So melting SiO2 needs to break many strong covalent bonds. These are part of like the common fixed essay that you need to be able to write. First of all, state the structure. After the structure, what do you need to break in the structure when you need to melt or boil the compound? Okay, so many strong covalent bonds. I have to use the correct adjective, which is to do with strong covalent bonds. Typically speaking, this will require a lot more energy, but I want to save that for the comparison because we are comparing 2 things. So I will state the structure and the thing that we need to break for the 2 individual stuff. And then after that, I will compare the energy required. So I will talk about SiCl4. It has simple covalent structure. So if you have simple covalent structure, that means you exist as a single molecule because molecular formula, the actual number of atoms in one single molecule. Only simple covalent structure can have individual single molecule. So when you melt SiCl4, you only need to break the weak intermolecular forces, but then that is more like an O-level style of answer. There's more like a 14 to 16 years old style of answer. Here you should be able to specify that this is just London dispersion, or what you call van der Waals or London dispersion, simply because your SiCl4 is actually non-polar. When you think about polar or non-polar, you think about Si and then 4 chlorine. So these are tetrahedral. Tetrahedral is a shape that you must know from organic chemistry, and of course, shape of molecule was all in the syllabus. 1, 2, 3, and 4. Silicon is like carbon, it forms 4 covalent bonds. So this is 4 bond pairs, and then 0 lone pair because the silicon uses all 4. 1, 2, 3, 4 out of 4 valence electron for bonding. You are left with 0 electron left on the silicon outer shell. The 4 bond pair repel equally. Tetrahedral 109.5 degree, just like methane. And because all the atoms are the same, when you have 0 lone pairs and all the groups or all the atoms are the same, when you have 0 lone pair, the dipoles will automatically cancel out. It's part of vectors, it's part of mathematics, it's part of mechanics. If you draw the diagram there, so this one is the dipole for that. And then you can draw like a parallelogram. So the dipole resultant dipole, the resultant force, just like in mechanics, they will cancel out to 0 because all 4 atoms are the same. When you have 0 lone pair, the dipoles will cancel out. Of course, the last point really is you need to talk about which one require more energy. So much more energy is required to break, much more energy is needed or is required to break strong covalent bonds versus the weak intermolecular forces. Of course, if you already specify this thing where you talk about breaking many strong covalent bonds require a lot of energy. Breaking weak intermolecular forces doesn't require a lot of energy. That should be okay as well. The next question, there's a decrease in the melting temperature for the series of chloride from sodium chloride. So I can say sodium chloride and then MgCl2. They are giant ionic structure. They have giant ionic structure, by the way. But then when it goes to AlCO3, it already starts to become simple molecular. AlCO3 and SiCl4 have simple covalent structure. So, you know, why is there a drop in the temperature? Because here you need a lot of energy, need much more energy to break strong ionic bond, because you are talking about ionic structure there. So you need to break strong ionic bonds versus weak intermolecular forces for the second one, because you have simple covalent structure. So the weak intermolecular forces is for that. And then the strong ionic bonds is for the giant ionic structure. It doesn't say sodium chloride and silicon chloride. It says sodium chloride to silicon chloride. From something to something, you must specify every single thing. Something and something, you just need to specify those two things. This and this, they are just two things. Silicon 4 chloride, all the way from sodium chloride, there are 4 altogether. You have to specify all 4 of them. It's kind of questions that kind of get repeated a lot of times, so make sure you know how to specify them very, very easily. This is again about the melting point. The main use of magnesium oxide is in this blast furnace, such as the one used to manufacture irons. So the extraction of iron from Fe2O3 was your O-level concept, and those things happen at very, very high temperature, and that's why the lining of the walls, they need to be made of materials that can withstand the very high temperature inside the blast furnace. Therefore, very high melting point is required for those materials. Again, we're talking about MgO versus MgCl2 here. So you cannot be talking about strong ionic bonds here, because ionic bond. So what we are doing here, really the context, understand the context of the question. The question here really is not like strong versus weak. It's also ionic versus ionic. If you think about it, it's ionic versus ionic. So when you have ionic versus ionic, what you're doing is you're going to compare the strength of ionic bonds. We can see that is the O2 minus and the Cl minus, they are different because the Mg2 plus and the Mg2 plus are the same. When you structure your answers, you might want to think about what you're doing before you do it. So both MgO and MgCl2, they have giant ionic structure. So by stating this, then I know both of them require breaking strong ionic bonds. So melting both needs to break strong ionic bond. So I am providing the introductory context. Okay, the strong ionic bond is between the oppositely charged ions. And in both cases, I have Mg2 plus. So in both, we have Mg2 plus, but different anions. So now you have to talk about the different anions. So the key factor here really is O2 minus has a higher charge. It has a -2 charge, which is bigger than -1. So bigger than -1 in Cl minus. What else do we know? Oxides and chlorides. Oxygen is in the second period, and then chloride is in the third period. As you go down each group, you have more electronic shell. So O2 minus has one lesser shell, one lesser electron shell, therefore smaller than Cl minus. Both of these will result in the stronger attraction between the Mg2 plus and O2 minus compared with the Mg2 plus and Cl minus, even though you have 2 of that Cl minus, but the attraction is going to be weaker because higher charge of the O2 minus and then smaller size of the O2 minus. This is what you will learn in A2 called charge density. Charge density of the anion. Charge density is charge over size, charge over volume. Density is mass over volume, charge density is charge over volume. The bigger your charge, the higher is the charge density. The smaller your volume, the smaller your size, the bigger is the charge density. The bigger your charge density, the more concentrated is the charge, the more they are attracted to each other. Hopefully that makes sense there, yeah? I don't know if you want me to go through the whole question really, but I thought it'd be quite nice to actually start somewhere because just now earlier at the beginning, no one had much question. If you want to draw the shape, to show the shape and the bond angle, you have to use a three-dimensional structure. We're talking about PCl3. So PCl3 is very similar to NH3. If you know NH3, NH3 has 3 covalent bonds between nitrogen and hydrogen. Now you can think of NCl3. Chlorines also form a single covalent bond. So when it's bonded to nitrogen, it's going to look like that. Then you can think of PCl3 because, phosphorus is just below nitrogen in the periodic table. This is exactly what the syllabus meant by you must know the basic stuff, okay? And then you can extend it to similar molecules. PCl3, so by drawing this thing here, this is not dot and cross. This is just for me to count the bond. The chlorine forms single covalent bond. The phosphorus like nitrogen form 3 covalent bond without any charge. And I will have 2 more electrons, which is a lone pair, just like in ammonia, when the nitrogen form 3 covalent bond. When I have to draw 3-dimensional structure, they are not asking for dot and cross, so do not draw dot and cross. They're asking for 3-dimensional structure that looks like this, and I have a lone pair there. So what can I say? Around the phosphorus atom, there are 3 bonding pairs. This is called valence electron pair repulsion theory, VSEPR. Then you say you never heard of it before. I'm going to suggest you to look at the AS syllabus under bonding. Under bonding, under shape of molecule, they specify candidates should be able to use VSEPR to explain the shape of molecule. Okay, so 3 bonding pairs of electrons and then 1 lone pair of electron. On the phosphorus, 1, 2, 3 bonding pair used up for bonding. These are pairs of electrons. It's called pair repulsion, electron pair repulsion theory. So we must talk about the repulsions. We have 1 lone pair. So what we must say is the lone pair, bond pair. So the lone pair and the bond pair, this one is naked electrons. The electrons are naked, they are exposed. These electrons are stuck in between the 2 nuclei. It's in between 2 nuclei, so they are less naked, they are less exposed. So this and this will repel because electrons and electrons, negatively charged and negatively charged, they will repel more than bond pair, bond pair. If you have lone pair, that will be the one that repel the most, but we don't have more than 1 lone pair, so we can just stick with this lone pair, bond pair. Lone pair, bond pair, repel more than bond pair, bond pair. However, we know that lone pair will repel more than this, will repel more than that. That's the full VSEPR there. Someone left a message in the chat. Okay, never mind. Okay, I saw it. Now the next thing, crystal structure of sodium chloride. Now this is one of those things. Yeah, people are so used to drawing Na plus where they draw something like this. You draw the. Actually, I don't want to draw the shell. The shell is very, very annoying. So you don't have to draw shells, obviously. So when you lose your outer shell, you're gonna get something like this. And then I use a dot for the 7 electrons in the chlorine, and then I have a cross, and then I have a negative charge. This is called dot and cross. This is not 3-dimensional. If you look back in your syllabus, you will know that ionic compound has something called giant ionic lattice. Sometimes weird definition come out. They will ask you what is meant by lattice. Lattice means, okay, your particles get repeated. It's an array of particles. They get repeated in 3 dimensions. Okay, so simple covalent structure does not have a lattice unless you are solid. Okay, but simple covalent structure, we talk about simple covalent structure. Usually we don't talk about simple covalent lattice. Okay, but giant structure is almost always a lattice. So here, you must have seen this diagram before, surrounded by 6 Na plus. So usually this is what happened in textbook. We show the Na plus is surrounded by 6 Cl minus. So these are alternating cations and anions because these are the giant ionic structure, alternating cations and anions. This is something that you would have already been able to describe from O level. So I'm currently teaching O level, and this is in the syllabus. Candidates should be able to describe giant ionic structure as alternating cations and anions. and they are tightly packed as a solid. So this is what happens in three-dimensional. This is what you put down on paper just to make it easy to understand that. Of course, they want around each ion. So, we can just draw the same thing. So it's actually octahedral coordination, very ordered structure, regularly arranged. So this is called coordination number. If you have done A2 transition metal, you are going to use this ideal coordination number. It means how many surround you, how many are around you. So here you have 6 Cl minus around Na plus. You have 6 Na plus around Cl minus. Describe the structure of sodium chloride. So altogether you get 1:1 ratio. So Na plus Cl minus, the formula cancels out to NaCl. So hopefully that makes sense there. By the way, each of these things is not a covalent bond. So not covalent bonds. And one more thing is ionic bonds, metallic bonds, ionic and metallic cannot be counted. They are uncountable, like sugar, like salt, they are uncountable. So when we draw this line, they're just to show the octahedral coordinations. Octahedral meaning, cutting top and bottom, left and right, front and back, okay? But they are not countable because ionic bonds is a force field. So the further you are away, the weaker is your attraction. In the next bit, why magnesium chloride cannot have the same crystal structure? Well, MgCl2 versus NaCl. The ratio of Mg2 plus is to Cl minus is 1:2. So not the same ratio of ions. This go back to your year 9. Define compounds. Compound is made out of 2 or more elements chemically combined in a fixed ratio. This is the fixed ratio for MgCl2 because the charges have to cancel out. So the fixed ratio is 1:2. The fixed ratio is 1:1. When your fixed ratio are different, how can they have the exact same crystal structure? They cannot. All right. Well, that's it really for the whole question. So hope they got your question answered and hope that is a good review and recap of your AS level chemistry. All right, next question. Anyone got next question? I can go to MCQ if you want me to. Whichever question you have.
Paper 1, question 7.
If you don't feel like talking, you can just leave a text message. I should be able to see it. Question 7. All right, so what do we have here? We are combining a pair of the resulting solution. So this is to do with the chemistry of oxides and chloride. Like I said, these are AS chemistry. You must learn to write on a piece of paper. What happens when you dissolve each of these in water. Sometimes it's fill in the blank, but you must be able to write all of them down on paper. So we know Na2O, this is a basic oxide. So it's a group 1 oxide. Basic oxide means it will dissolve in water to give you a base. If I write that down with water, they'll just give me NaOH. Do not write any equation which are not balanced. You can clearly see that it's not balanced. In paper 2, you will be penalized. This is an acidic oxide. SO2 can cause acid rain. But what is the number 1 mistake? The number 1 mistake is H2O plus SO2. People thought it will form H2SO4, which is actually wrong. So in order to do this, you must be aware, you must follow oxidation number. Sulfur plus 4, because each oxygen is -2 there, plus 4, -2, the compound, the molecule has no charge. If you start from sulfur plus 4, when you react with water, you are just dissolving in water. You are not doing redox. So your product must have sulfur plus 4 also. In your paper 3 practical, ever since O-level or GCSE or IGCSE, ever since your practical days, you have already been taught about SO4 2- versus SO3 2-. This is sulfate, this is sulfite with the ITE. I know for a fact this is still in the AS level practical, so do not say that it's not in the AS level practical because it is. This is a sulfate with the ATE. This is a sulfite with the ITE. There are different tests. There are different tests for sulfate and sulfite, and that can come out in AS paper 2 as well, because anything from the practical can be asked in theory. And in theory paper, you do not have that 2 pages of analysis table results. So if you've done practical, if you rely on the table your entire life, when this comes out in paper 2, you cannot blame the examiners. Okay, that's all I'm telling you. Because we are dealing with sulfite, since we want sulfur plus 4, our product here will be SO3 2-. It's an acidic oxide. We get an acid. An acid contains H+. So you're going to combine H+ and SO3 2-. So that means you're going to get 2 of the H+ and 1 of the SO3 2-. You're going to get H2SO3. This is not sulfuric acid. This is the sulfurous acid, which comes from the sulfide ion. So just be aware of equation and be very careful when the SO2 reacts with Na2O. I know this is not a question here, but I'm just saying when the Na2O reacts with SO2, because this is sulfur plus 4, you get a basic oxide, you get an acidic oxide, you're going to get neutralization. There is no water because there is no hydrogen. Since these are just oxide and oxide, you don't get any water because even though it's neutralization, there is no hydrogen to begin with, unless you add water. Then this and this will have water. The salt, you're going to get a salt. The salt that you get will not be sulfate, because the number one mistake is people do not remember about the oxidation number. When you are forming a salt, it is not a redox. Neutralization is not a redox. This is called neutralization. Neutralization is not a redox. If it is not redox, you cannot form a sulfate, which is SO4 2-, which is sulfur plus 6. In case you don't know, of course you should know, but in case you don't know, -2 is the charge of the ions. So -2 is the overall oxidation number. Sulfur, there is 1 sulfur. There are 4 oxygens. So 4 times -2. So sulfur is -2 plus 8. Move the -8 to the other side. So sulfur there is plus 6. I'll leave you as an exercise to convince yourself it's sulfur plus 4 here. These are case studies which you should have done when you first did periodicity. Instead of memorizing a lot of things, try to go back to basics and think about what you were able to do and use that to build new knowledge. This is going to be Na+, and SO3 2-, the salt. So 2 of the Na+ and 1 of the SO3 2-, you're going to get Na2SO3. So this equation will be balanced just like that. So be very careful there. SiCl4 is a chloride. So when you dissolve SiCl4 in water, you're going to get hydrolysis. This is a common question. You're going to see a white precipitate. So this is a white solid. As you know, silicon dioxide, silicon 4 oxide, insoluble in water. It's a component of white sand, the sand that you get in Telisai, in Tutong. So that white sand will not be soluble in water. It's a white solid. As a result of this hydrolysis, you also release HCl. Of course, every equation you write has to be balanced. They love to ask you to write this equation as, yeah? So 4 chlorine there, so 4 there and 2 there. So you see a steamy white film. So you say that you get a steamy white film because you are breaking some covalent bond and you're breaking some covalent bond. You are forming giant ionic structure. In case you forget, I am using this opportunity to recap quite a lot of stuff. The oxygen there is bonded to 2 silicon. Each silicon is bonded to, oops, sorry, not that's wrong. Each silicon is bonded to 4 oxygen. Each oxygen is bonded to 2 silicons. It is going to be bent because it's got 2 lone pair and 2 bond pair on the oxygen. So 104.5 degree. But around each silicon, you will have 109.5 degree because just like methane, just like CH4, you have 1, 2, 3, 4 bond pair and no lone pair on the silicon tetrahedral geometry. Why am I talking about all of these things? Because these are all components of inorganic chemistry, structure, bonding, shape, what else? Chemical reactivity, writing equations. Those are all very usual stuff, very, very usual stuff when you talk about periodicity. Yeah? And of course, that includes the elements, the oxides, the chlorides. Those 3 are the important case studies as stated in the AS syllabus, which you should go through one by one. If you want to do well in inorganic chemistry, if you want to do well in the AS chemistry or A-level chemistry, do not skip anything in the syllabus. Okay? So what you're going to get, even though this is steamy white film, but some of them will remain in water. So what you will get is you get an acidic solution also. and an acidic solution. So how about this NaCl? NaCl is just pH 7. They just dissolve in water. So it's what you get when you dissolve salt in water. You just get pH 7 salt solution. They don't do any hydrolysis. So no hydrolysis at all. The pH remains pH 7. When you react NaCl with Na2O, so this is pH around 13 or pH 14, because you're going to get sodium hydroxide, which is a strong base, 13 or 14. You're not going to get a pH 7. You know, base and neutral, you're going to get basic. So A is wrong. To get the neutral, most likely it will be two scenarios. Neutral and neutral. Neutral and neutral add together will get neutral. Okay, not just acid and base, yeah? Acid and base, yes, acid and base will become neutralized, but neutral and neutral will also be neutral. So just be careful, okay? And NaCl is neutral, so pH 7, and then this one is pH, may give you an acid. This is a strong acid, so pH 2, pH 3, pH 1 will be okay, so not bad. What else can I say? SiCl4 SO2, this is acidic, and this is acidic. Acid and acid will give you acidic solution. So it's really coming down to this, because this one in water, SiCl4 in water will give you acidic solution. Acidic solution HCl can react with Na2O, will give you, what do you get? Na2O plus HCl. The HCl comes from the SiCl4 hydrolyzing in water. You're gonna get NaCl plus H2O. Of course, balance your equation like that. Okay, hopefully that makes sense there. And obviously it's a good recap of the other associated concepts as well. And when you do this kind of question, when you do revision, take opportunity to recap at every single opportunity, yeah? Not just doing the question. Unless you're in an exam, then obviously, you know, just do the question. Okay, next question. MCQ structure, just shout out. Anything? You can leave a message in the chat if your mic is not working or something. Hello. Any further questions? We have another 20 minutes, so you know you can make full use of me. You can ask MCQ or structured. Again, these are stuff which you should have done previously, and these are stuff which you should have covered before the class. And then you have questions to ask. I know AS is coming up. Can be a bit scary, but I try to help. So, you know, you have me for another 20 more minutes. Any questions, please shout out. Just unmute yourself and shout out, or just leave a chat message.
Question 23.
23. Multiple choice question is very good to test whether you know your stuff or not, yeah? Now, there are 3 questions actually in catalytic converter. This one said does not remove, so not effective. Now, first of all, what are the effective equations? In the structured questions, you must know 3 equations for catalytic converter. Catalytic converter, it converts dirty gases, harmful gases into clean gases, harmful into better gases, toxic gases into less toxic gases. Excuse me. If you look at this thing, carbon monoxide is toxic and also poisonous to us. So that one is bad. There's the hazards. Hydrocarbons can cause photochemical smoke, SMOG. These are the dangers, yeah? Sometimes you get in AS 1 or 2 mark question, what are the dangers, right? Oxide of nitrogen, it can cause respiratory problems, respiratory distress. And then, of course, that can result in acid rain as well. So, etc. And then you can cause acid rain as well. So these are the individual dangers. So it's bad. So the gases coming out should be better, less toxic, less harmful. That is the whole purpose of catalytic converter. The first one, of course, is you're going to get, so I'm writing a series of equations which you must know in theory paper, yeah? Carbon monoxide, you burn it completely, then it becomes carbon dioxide. Harmful gases going in, better or less toxic gas coming out. It is a greenhouse gas, it causes global warming, but it doesn't kill you as much as carbon monoxide. So better gases coming out. Now, the second one is to do with when you have NO. NO is bad, CO is bad. When they come together, the CO is going to take away the oxygen from the NO. You're going to get CO2. Harmful going in, better coming out. That's the whole idea of catalytic converter. You take away the oxygen from nitrogen, and then I get nitrogen. That is not correct. Nitrogen does not exist as nitrogen atom. As you know, well, even O-level student would know, it exists as diatomic molecule like that, so it exists as N2. And even O-level students would know, do not ever write equations which are not balanced. If you write even one equation which are not balanced, you lose the marks. As simple as that. Could be a very simple equation, you lose 1 mark straight away if your equation is not balanced. You write everything balanced, you write everything correct, formula correct, but your equation is not balanced, 0 mark. It's the rule of Cambridge, okay? You can read in examiner report. Now the next one is called unburned hydrocarbon. So CXHY, and you know this complete combustion equation, X plus Y over 4O2. They just give you the complete combustion product. Incomplete combustion will give you CO, but the CO can be converted to CO2. Unburned hydrocarbons, how do you clear it? You burn it completely. How do you burn it completely? Complete combustion equation, carbon dioxide and water. Harmful going in, better stuff coming out. Looking at this series of equations, we are looking for does not. So why do I write these 3 equations? Because in the theory paper 2 question, they can ask you how or express using equations, plural, yeah, plural. So they'll give you 2 or 3 marks. Explain using equations how catalytic converter remove harmful or toxic gases. They don't tell you which gases, so you have to know at least 2 or 3. In fact, all 3 of them, I guess. Now, the first one, I can tell you the answer is definitely A, because you are removing harmful oxide of nitrogen, but you are producing harmful gases. So still around, still harmful. If you look at the other one, the N2 is okay, the CO2 is okay. That was my second equation. And this one is still okay. N2 is okay, CO2 is okay, H2O is okay, CO2 is okay. I haven't written down equation for C here because this is probably quite hard to understand. But as you can see, harmful hydrocarbons, harmful oxide of nitrogen, these are better stuff coming out. So this question is, does not work, does not remove the hazardous polluting gases. This is still hazardous, this is toxic and poisonous. Hopefully that helps you to understand the questions. Okay, next question. 24, MCQ. So this is a qualitative analysis. Qualitative analysis QA starts from paper 3 O level as well as A level. You will not be given the result, the 2 pages results in theory paper. When they ask you if you don't know, well, that's it. You just don't know. Okay, so make sure you know your table of results. Yeah. What do we have? We have 2 cations, one of which is Fe2+. If we have Fe2+, we are trying to identify the second cations with solid sodium hydroxide. So when I heat it, so I add an OH, then I heat it. Then I get a gas, which is colorless, and it dissolves in water, giving an alkaline gas, alkaline solutions. So I get an alkaline gas. This one should tell you when you add NaOH and then you heat it, you get alkaline gas. It will, they don't say it, but this one will turn red, lemon, blue because that is the test for alkaline gas. The gas must be ammonia. If the gas is ammonia, the ion that is present when you work backwards, the ion that is present must be NH4+, because you should be able to write an ionic equation. NH4+ aqueous reacts with OH minus aqueous, will give out NH3 gas, and it will kick out H2O liquid. This is called ionic equation because it works for any ammonium salt, it works for any hydroxides, and it will give you ammonia gas that turns red, lemon, pepper, blue. Now, what does this mean? This means the NH4+, the NH4+ is losing H+, so it's acting as a base. Proton donor. Oops, sorry, it's not acting as a base, it's acting as an acid. It's not ammonia, it's NH4+, it's losing H+. The OH minus is accept H+. Proton acceptor is a base. When the OH minus accept the H+, they get neutralized H2O. But in this reaction, you also kick out the NH3 gas as the ammonium ion releases or loses the H plus there. Okay. What else? They don't call this neutralization because you are not producing something which is neutral. This is alkaline. So they call this reaction displacement of ammonia, as you would know it from O level when you were 14 to 16 years old. So this colorless gas must be NH3 because it's the test for ammonium. This is stated in your test for cation. You add NaOH to this salt that contains NH4 plus. You heat it, you're going to get this alkaline gas, which is ammonia that turns red lemons pepper blue. You will write all of this observation down in practical paper because that is what they've been told to do ever since you were, I don't know, 14 to 16 years old. Now, blah, blah, blah. A gray-green solid was also formed. Why do you get a gray-green solid? Because you have added NaOH. Not only you have one cation, you have two cation. The other one is Fe2 plus, so you're going to get iron 2 hydroxide. And this iron 2 hydroxide is green in color, although it will turn brown on the surface. It will turn brown on the surface as it gets oxidized very easily. So that's going to be option C there. Okay, as you know, iron 2 hydroxide, just like a lot of the metal hydroxides, they are pretty much insoluble, even in excess NaOH. Okay, next questions. Structured MCQ, just shout out. Or leave a text or something.
28.
28. Okay. This is part of group 17, halogen chemistry. This type of question is very popular. So what is the main concept that's required? The key concept that's required will be, think about oxidizing power. You must be able to do this oxidizing power thing. Chlorine Cl2 molecule is a stronger oxidizing agent than Br2 than I2. Okay, and where is the consulfuric acid? This is a case study. Consulfuric acid lies somewhere there. So we know that consulfuric acid with chloride, it cannot oxidize chloride to chlorine because consulfuric acid is a weaker oxidizing agent than chlorine. So it will only undergo acid-base reaction with Cl minus. So no redox. So consulfuric acid and Cl minus, no redox. That is the key thing. Only acid-base. But then you will see that consulfuric acid is a stronger oxidizing agent compared to Br2 compared to I2. So this thing can oxidize Br minus to Br2. This thing can oxidize I minus to I2. And in doing that, when it acts as oxidizing agent, it oxidizes the other substance. You yourself will get reduced. You will get reduced to SO2. It stops at sulfur plus 4. But here, for I2, you can get SO2, you can get sulfur, you can get H2S. So what is the difference between all these three? The sulfur plus 6, where in the world is the sulfur plus 6 coming from? There's your question. H2SO4 is a molecule with 0 oxidation number because the whole molecule is uncharged. Hydrogen is plus 1 here because it's obviously a proton in a compound like this. Sulfur, and then 4 times minus 2. Each sulfur is plus 6 oxidation number. It's a case study. You might need to, really know how to get it and be able to do it very fast. The sulfur plus 6 will decrease to sulfur plus 4, will decrease to sulfur 0, will decrease all the way to sulfur minus 2. This is the lowest oxidation number that it can go to. Group 6, group 16, it has got 6 valence electrons. 1, 2. When you add 2 more electrons, fully fill outer shell. So that's why it doesn't go any lower than minus 2. This is the lowest it will go to. And then you can think about these sulfur, you will see a yellow solid. So it's a yellow solid. And then H2S is the rotten egg kind of smelling gas. So it's a gas that smells like rotten egg. Really, really very bad smell, yeah? SO2 has a suffocating kind of gas, suffocating gas. If you smell it, it's like smelling chlorine, but actually it doesn't smell like chlorine. Chlorine smells like swimming pool, but SO2 will kind of suffocate you. If you have asthma, it really makes you quite difficult to breathe, okay? So it is colorless, but it is not odorless. It's got a smell to it. And what will happen there is the I minus 1 will go to I0, which is iodine molecule. I0 in I2. So you will see a gray solid, you will see a purple vapor as the reaction is exothermic. you will see Br minus going to Br2. So you will see a reddish brown liquid. You will see a reddish brown gas as it vaporizes as well. You will not see pale green gas because there is no redox. Consulfuric acid cannot oxidize Cl minus to Cl2. You just stop at acid-base reaction. This question is not asking on that. Why am I talking about all that? Because this is a good opportunity to revise and recap this halogen chemistry at this junction. What do we have here? As you can see, with the chloride, you just get colorless acidic gas. You do not get pale green gas. So the fact that it's colorless, but then we know Cl2 is pale green. So we only get colorless acidic gas, and that is because you only get HCl, only HCl. So that means if consulfuric acid only gives you HCl because there's no acid base, you must be able to write an equation for this. So consulfuric acid plus, I don't know, NaCl. So what happened is this one acts as an acid. Acid donates proton. Acid donates proton. I mean, that one you should pretty much know now. If this is acid, it donates protons. So what would be the other one then? The other one would be a base. It will accept the protons. The Cl minus accept the H plus. You get HCl. And then you will produce a salt. So you get Na plus, you get HSO4 minus. This is called the conjugate base. Conjugate base is an AS term. Conjugate base is what you get after the acid donates the proton, you get conjugate base. This is the conjugate acid. Conjugate acid is what you get after the base accepts the proton. These are definitions under AS, acids and bases equilibrium. I have produced Na plus HSO4 minus because this is the easier one to see. As you lose one H plus, you now only have one lesser H plus, you have a minus charge, these two combine to give you a salt. People don't like this because people are so used to sulfate, sulfate, sulfate. It's okay. You can write your sulfate and it will still be correct. If you write Na2SO4, it's perfectly fine. Okay. What is not fine is when you write this, your equation is not balanced. So you have to write a balanced equation. If you write these equations, product can be correct. Okay. However, if you write this equation, leave it like that, you get 0 mark. Not because your product is incorrect, but because your equation is not balanced. You need 2 of that in order to balance the sodium, and you need 2 HCl to balance the chloride, and 2 hydrogen there, 2 hydrogen there. I can tell you both of them are acceptable, both of them are correct, but it's always been my usual habit to just write this because it's easier to just see lose one H plus, and then you just balance the equation easily, rather than having to worry about balancing the equation. This is an acid-base reaction. So acid-base reactions, as I've just shown you, there is no redox because this thing is not strong enough to oxidize the Cl minus, minus 1 in this HCl. So what we are saying is conphosphoric acid must be also weaker than chloride. But is the conphosphoric acid left-hand side or right-hand side of the consulfuric acid? Well, we have to look at the other one. Okay, so there's no redox here, no redox there. When you look at sodium iodide, iodine is all the way down there. We get a purple vapor. Purple vapor is iodine as a gas. Iodine as a solid is gray solid. It will sublime to give you a purple vapor as iodine gas. Here, you only get colorless acidic gas. So again, no redox, only acid base. No redox, only acid base. That colorless gas is HI gas. So if you imagine this is NaI, you're going to get HI and then Na plus H2PO4 minus, which is just giving off the HI gas. But there's no redox. If there's no redox, there's only one conclusion you can make. That is, conphosphoric acid must be weaker oxidizing agent than I2. It must be lower than I2 so that it cannot oxidize I minus to I0. That is why you don't see purple gas. That is why you only see acid-base reaction and no redox. It must be weaker oxidizing agent than I2, sorry. So here it says it must be a stronger oxidizing agent than consulfuric acid. No, it's not. It is weaker. Going this way is stronger. Going this way is weaker. So this is wrong. Conphosphoric acid is stronger oxidizing agent than iodine. No, it is lower than iodine. That's why it cannot oxidize iodide to iodine. You only get acid-base reaction, no redox here with iodide. Consulfuric acid is stronger oxidizing agent than chlorine. That is not true. You only get redox with bromide and iodide, but not with chloride. When you use corn sulfuric acid, that one is a case study. So again, D must be correct then, because corn sulfuric acid is a stronger oxidizing agent than that, as you could get all these three products, as they are your case study from AS Group 17 Halogen Chemistry there. Hopefully there's a good revision. I don't know whether that was useful or not, but I've talked about a lot more things than what is required in the question, and you should know how to get one of these equations. I'm going to show you one equation. Yeah. So when you produce HI, the HI was produced from the acid-base reactions, the HI or the HCl. Now what's going to happen with this is it will react with corn sulfuric acid, and let's say we produce H2S, hydrogen sulfide product. Of course, you could produce S or SO2 as well, but I'm just going to show you one equation. You will get this I2, as this get oxidized to I2, and you will get water. This is stated in the redox topic. Use changes in oxidation number. Use changes in oxidation number to balance equation, to balance redox equations, because only redox equations can have changes in oxidation number. Follow carefully, and you can do this with any redox equation. Iodine -1 there, sulfur +6 there, sulfur -2 there, iodine 0 there. Okay, work out the oxidation number. That's the first thing. The next thing is +6 to -2. Can I have, I don't know, Rahiman, can you tell me what is the change in oxidation number here? What is the change in oxidation number? +6 to -2?
-8.
-8 is correct. Some students thought it's -4, but it's not. If you go through 0, this is +6. There are 6 units there. And then when you go to -2, there's 2 more units there. So do not get this wrong. Otherwise, the equation will not be balanced. This is -8. And then -1 going to 0 is +1. Use changes in oxidation number. When you do half equations, you have to get the electrons to cancel out. This is the same thing. You have to do lowest common multiple, primary school mathematics. This has to be multiplied by 8. If you have to multiply the pink one by 8, the iodide must be 8 of them. So it must have 8 HI. Afterwards, this is iodine 0, so it doesn't matter how many multiple you multiply it from, but it's also a molecule. This is multiplied by 1 because -8 times 1 will cancel out +1 times 8, which is +8. So I just have 1 and 1 there. So 8 iodine, so there should be 4 I2 molecule. And then the hydrogen, 8 hydrogens, and 2 hydrogen there can balance the 2 hydrogen, 8 hydrogen, so I need 4 H2O, and this equation is balanced. You can try other equations like HBr plus that, and then you get SO2, and then Br2 and H2O. You can try using the same technique to balance your redox equation as well. Okay. Actually, before we go, can we just all take a quick photo for attendance, because there is what they need for us. So if you just quickly turn on your camera and we can just take a quick photo. Where are we? So this is the last time I'll see you before the school closes. Yeah. So hopefully everyone find that useful. All right. So. Okay, smile, you're on camera. 1, 2, 3. Let's just take one more. 1, 2, 3. Okay, so feel free to turn off your camera now. So we're just about ending. But before I go, I guess I don't know if I'll see you again before your June AS. Probably not. But I've got all sort of topical playlists like MCQs and stuff on the channel. So more than welcome. You're more than welcome to use as much as you want. So those things are on the channel, and if you don't know what you're looking for, just email me or something, or leave a message on the Google Classroom, and I'll try and get back to you. In terms of the structured questions, there are also topical playlists as well for the structured questions on the channel. So hopefully you know what you're looking for, and hopefully they'll be useful to you to some extent. And they are free to use, so feel free to share them with other people as well. I'm afraid that's all the time we have. You guys came in a bit late. When things start at 8 o'clock, they start at 8 o'clock, yeah? So make it a habit of never being late, even though it's online. And yeah, you don't want to be late for the exam. Okay, so get enough sleep and yeah, rest well, and hopefully you do well in the exam. Okay, thank you everyone.
Thank
Thank
you,
you,
sir.
sir.
Okay, bye-bye.